Okay, hello guys, welcome back. We're gonna do NMR processing for basically your amusement and your reports. So this is e-learning, and what I've added here is a link to the free NMR processing suite, ACD Labs. You click on that and you'll get something that looks like this. You can go download it after you do some registration and jump through some hoops, alright? Now, it's a PC only program, so if you're lucky enough to have a Mac, you're going to have to emulate Windows, but if you're on a PC, it's pretty easy to do. You download it, and then you run it, and let's go to a PC real quick. Oh, look, I'm at a PC. Do we need to plot NMR? Oh, yeah. Go away. Kathy, you wrecked it. You wrecked it. You wrecked it. No, I'm just kidding. You didn't wreck it, really. All right. Click, and then you're going to do NMR processor. All right. So, what we're going to do is going to go File, Import, from NMR directory, and you're going to grab the spectrum of ALQ, which is going to be this one. All right. And sometimes you click around and there you go. You get a preview of it right there. You might even get a preview that looks like this, where it's all done, which is great. But if you didn't, and it looks like that, we're just going to go from here. All right. And click Open. And what you have here, now this is what you call the free induction decay. All right. And it's raw data that comes out of the spectrum. And to get from the free induction decay to the spectra, you're going to do a Fourier transformation, and that button's right here. You just click it, and the Fourier transformation is done for you. Now what you'll see is that you have some sort of weird amplitude problem where it goes up to a value and then it goes down to its negative value. And obviously your phasing is going from positive to negative phases, and you don't want that. Everything we do is positive phase. So you go up here to phase, click phase, and you may have a box in the way. If it's in the way, you scoot it out of the way. And then you click Auto Simple. Should be fairly straightforward. And then you end up with your peak. Alright, so let's really quickly talk about these peaks. I want you to be able to sort of look at it and do it yourself. Now there are a few things that you should probably realize is that, you got peaks. Alright, this big peak right here, that's most certainly chloroform. This peak down here is your reference peak. That needs to be at 0. That's tetramethylsilane. This peak right here, it's a 1.5. It's water. This guy right here, probably methanol if I had to guess. Definitely not part of your ALQ because nothing should be at that resonance. Almost all of your interesting stuff is going to be between 7 and 9. All right. So what we can do is, since we're going to focus on 7 and 9, we need to first reference. So you get a reference, and since we're already out here, we're going to go reference this guy, TMS. It needs to be at 0, so you come over here and you just scroll down and look for TMS. Make sure you click TMS 0, and that basically moves everything so that now it's all set and right. Okay, green check mark is good, and we're going to zoom in. And you can pick one of these rectangular zoom boxes. Fine. Click on this guy. Zoom in here. There you go. All right. Now, this could be really confusing if you don't know what you're looking for. And you may not. But what you should appreciate is that what you've got are a couple peaks right next to each other. All right. Looks funny. All right. One particular thing is that this spectrum is not ridiculously pure, but if we just do the integration, I'll integrate the peaks that they're supposed to be here. And this peak is clearly going to be here. It's supposed to be there. And it sort of gave me a number of 2.98. I want to set that to 1, so you get a reference. You reference that as 1. Alright, that's 1. And we go and draw over this peak, just this section right here, that should also be 1. And 1.02, very close. We go down here, we do this integral, draw over that, 1. Good. Over here, draw this. It should be 2, which it is, 2. Alright, and then you've got some spinach over this side, which in this particular instance is going to grade out to 0.5, but that's fine. And then you've got a bunch of stuff over here. That all integrates out to a lot. Alright. Well, there you go. Now you've got your integrals. You need to know what your peaks are, so click your green check mark, and then peak picking. Auto. There are your peaks. Alright. Check mark. Good. Alright. So I guess we can have a chat about this sort of individually when you start trickling in your drafts, but you quickly what you'll see is that this should be 1 proton. This should be 1 doublet, not 2. Certainly not 3. Not 2. I mean, it could be, I guess, 3 in principle. And so, based on what you know about symmetry of the overall complex, you should be able to make a decision as to what isomer this structure is. And based on your quizzes, I think maybe we should just really quickly go over it. All right, let's just really quickly go over it. All right, this is naphthalene, very symmetric molecule. You'll notice up here, these 4 protons, exactly the same as these 4 protons. That means that in the NMR, because they're symmetrically equal, they're going to be shifted. Their shifts, chemical shifts, are going to be equal. Just like these 4 protons on this side, same as these 4 protons on that side. And that means that of all these protons, only 2 are really unique. And that's the proton here, which is the same as this one, same as this one, and same as this one. And the proton here, which is the same as this one, same as this one, same as this one. All right, by symmetry. You should only have 2 unique protons on this whole molecule. Now we go up to our molecule. You've got 1, 2, 3, 4, 5, 6, 7. You'll notice no symmetry here, no symmetry there, no symmetry to the left, no symmetry to the right. All 7 protons, totally different. All right, total of 7. If you have no symmetry, that means each proton technically could have its own shift. Doesn't necessarily have to, but it could have its own shift. Symmetrical molecule cannot have their own shift. This must be the exact same shift as this, because they are symmetrical. Just like this must be the same shift as this, because they are symmetrical. Okay? So, you think back to which isomer is symmetric and which isomer is asymmetric, and then you can appreciate that clearly you've got asymmetry in your overall complex. And I'll leave it at that. And we can go further individually if you'd like. Now what you need to do is be able to generate into a report. And this is a little tricky. Alright, so you go up to this little guy right here. It says copy report to report editor. Click. And then you just click OK. And then it generates a bunch of crap. Alright, I don't even know why. Chem sketch, what? Okay. No. Alright. You may have less crap than this one. I have to go all the way down here to this button, click the page 2 to get to the spectrum, and there you go. Alright, so there's my spectrum. I really only want this part of the spectrum. So I can move it around if I am so careful. But if I select that, get the box, I can go edit, copy, file, new, edit, paste, default, and then it's kind of got this thing stuck, and I just paste it there. Alright, and then in principle, I just sort of size it up. I can declare victory and say file, save as, PNG. I'm going to put it on the desktop. I'm going to call it the ALQ spectrum, alright? Save. And I've already done this once. And then close. I'm going to save changes. I'll not close it, we'll just minimize it. And we see we've got the file right here. We double click on, what is this? What have you done, Windows? Alright, let's just go to Mac. Mac view, I know how to use that. Click on that, boom. There's your spectrum. It looks real great. Real great. Alright, so if we go over here to your template. So, you got your template here. You want to put your spectrum in it. You just drag your spectrum right into your template. That's it. And then you can say, I need to call it figure 1. Oops. Figure 1. Proton NMR spectrum of LQ complex. Alright. When you want to do it proper, go highlight it. Actually go up here to figure 1. Beep. There. Oh, that's so cool. And then you can keep typing. Alright. That's how you do it. Good luck.